If you've ever had an augmented reality experience in the construction industry, whether wearing a HoloLens 2 headset or working with your mobile phone or tablet, then you've most likely experienced drift. And essentially what drift is if you have a large building information model or digital asset, you place it in the world, and then you're trying to walk long distances, say along an entire floor space or on a project site, then sometimes what will happen is the model will start to basically drift away from the actual overlay in the real world. And this can become problematic because then you start to not trust the 3D model, and it doesn't look right and doesn't look placed correctly in the real world. Now, it's pretty important to understand how these hardware devices work and how they create an augmented reality experience for you. Well, essentially, first, they have to understand and scan the real world, and they have to get a 3D mesh of that. They actually look at pixels from photographs and are understanding and creating a map, essentially, of the physical world. And this is important because when you put digital assets or holograms, essentially, in that real world, they have to have a position and a coordinate system, and then also there needs to be an understanding of where you're at in the physical world relative to everything in your surroundings, as well as the digital assets that you place. And so there's a variety of different input things that are happening on both headsets and mobile devices that also feed information to the software applications in order for you to get that seamless experience. Now, one thing that's been out for a while on mobile devices is LiDAR, and this is light detection and ranging. And essentially a key piece of this is it creates depth perception and understands distances of the physical world from your device itself, which is really critical because this mapping is needed in order to make sure that the distance between physical objects where you've anchored holograms and things like that are stable. So in construction, the challenge is that you could have an entire floor plan or you have a large job site, and essentially you could be moving hundreds of feet from one location to another. And that's going to be outside of the bounds of basically air when it comes to these devices. And so what happens is a lot of software companies are creating things that allow you to create these spatial anchors in different locations in the job site. So again, the way that these spatial anchors work is that it's an origin point to the coordinate system of placing your digital assets in the real world. And essentially, the computer or the hardware device actually needs to calculate and understand and deliver information between where you're located, where your head is located, how you're looking in the real world, and it needs to map how the digital asset, you in your position and your looking direction, and then the actual map that it gets from the real world and how that all works together. Now, there is a range of accuracy here where that will all sync together seamlessly and feel like a real experience. Once you start getting outside of that, then the calculations that are involved in actually doing that placement and sending that information back and forth starts to get a little bit too inaccurate, and then you have an experience that doesn't look real or that you can't trust. And so this is where basically these software applications are creating a network of different alignment points or spatial anchors throughout the job site. And then this also allows you, as you move from one location to another, to basically realign the model to that specific location or environment that you're in. Now, this isn't just for one person. If you think of a real construction job site, we're going to have multiple people out there working, doing inspections, and they're going to be in multiple locations at the same time. And they're going to be working with multiple devices. So it's important for if you're going to do persistence, where you're going to keep a memory of these spatial anchors versus scanning every time you go out to the job site, which is tedious and somewhat irritating and time consuming. But basically, if you have these alignment anchors in place and you store this information in the cloud, not just on the individual device, then essentially you can share the information that the person has done from creating alignment points and spatial anchors in different locations. You can store and share that information across multiple users and multiple devices. So then a lot of people ask me, hey, I'm just going to have a bunch of QR codes posted across the job site, and then I'll just scan those each time I go to different areas. And this does help a little bit in the initial placement, but it doesn't truly track and remember things, and you do have to constantly scan it as you're going to different locations. I've noticed in true reality when I test these, sometimes these are not placed in the right spot. And then also I've still had to deal with doing what's called refined alignment, where you still use an alignment cube to kind of move things around and get it exactly where the digital asset is overlaid with the real world. And so this is only solving part of the problem. And so when we actually take a look at the Trimble Connect HoloLens app, this is a screenshot showing you a physical persistent anchor being placed. And so again, the idea with persistence here is that I am trying to create a origin point here in the real world and tie that and remember that to what the HoloLens sees and maps in the real world, and kind of remember that. So that way the next time I come back here, I go, okay, hey, I recognize this origin, I recognize this location, and I need to place the digital model in the real world to this thing that I recognize. And in that way, you're not having to do that refined alignment over and over. Now, another neat solution that Trimble has done is actually tying their robotic total stations and allowing an operator to walk around site with a prism that communicates back with the robotic total station. And so this sends another feedback loop to the HoloLens and the layout software in guiding the user to more accurately place points or see things and position things in space. Now, the robotic total station is going to be placed over a known survey point or location point on the job site. And then again, they have a level, a fairly great distance of accuracy in communicating between the operator holding the prism and then tying that back to the robotic total station. So we've also taken a look at Argyle Build in a couple of my other videos, and they have a system like this where essentially as you walk through the project or the job site, you'll start to see the drift. And so what you do is you go through and you set one time only, you're going through and you're setting all of these different anchor points or alignment points. And then as you in the future or the next day you put the headset on, it will retain this information. And so as you move from one location to another, get closer to another anchor point, essentially what it'll do is it'll say, hey, okay, I need to move. I'm scanning the real world. I recognize this anchor point. I know where I need to move and align the 3D building information model to those anchor points to create a seamless experience. Then we can take it to another level of accuracy, especially in a manufacturing or a fabrication shop environment. And here we're looking at some imagery from Fabrication Station Steel. And what's fantastic about this is I need a 16th level of accuracy between the holograms and the actual steel, especially if I'm going to try to use this for layout and fit up, or if I'm going to use this in quality control. I'm going to want that high level of accuracy because I need to tape measure and make sure everything's to a 16th of an inch. So essentially you need to kind of look at the different use cases and what level of precision and fidelity that you need in working with the technology. Now, another set of major challenges that have to be overcome with augmented reality and construction projects is that construction projects and buildings change over time. So you start out with the earthworks and then concrete foundations and footings, the structural steel frame. Then you have the interior stud walls, drywall, MEP, and then the exterior envelope. So really the building evolves over time. So the challenge with that is if you're creating spatial anchors or alignment anchors that are based on tying to physical scan geometry by the hardware devices, well, then the problem is you might have to lay that out a couple times because the job site's going to change. Now, one other key thing to understand, and when you actually look at a lot of mixed reality and augmented reality cases, you're going to see in a lot of instances where they're shown more on the right-hand side image, especially with like MEP, and where basically the canopy or the covering floor of the building is already in place. And so just from using the hardware and mapping from like a 3D mesh of the real world and looking at features and things in the world, there's a lot more difference or contrast essentially in the image and the stage of the building on the right, which is in a lot of sense better for the hardware. It actually creates a better physical map because it's not just creating a 3D mesh, it's actually using a variety of different things in order to understand its physical environment and map to it. When you have a really kind of open field and open space environment on the left, or let's say you had a concrete slab with a lot of repetition there, and there's not a lot of features or variance along that slab or on a concrete wall, well, the challenge is that the hardware is having a hard time trying to look and distinguish that, hey, you're moving to a different location based on what it's seeing. Because it's not just positional and not just a mesh, it's looking at the features and things that are on the walls or throughout the space in order to create a complete map of exactly where you're at. And so these are some pretty significant problems. The end user, again, should not have to worry about this, but a lot of people don't understand why is it that, hey, people are using this at different stages of the building, building and in a certain application compared to others. Now, as a structural guy, I'm excited about the technology being able to be leveraged for like panel wall layouts, concrete footings, rebar placement, precast panels in a manufacturing environment. Even structural steel to verify placement or sort of communicate what's going to be going on, or with miscellaneous steel and things like that. But again, it gets a little bit more challenging because you have to create certain things out on the job site that enable the technology to kind of understand where it's placed and where it's at. And usually what you do is you add temporary type features and things to make that possible. A few other challenges that have to be overcome with mixed and augmented reality on construction sites is, first of all, there has been oftentimes, especially with the HoloLens, what I call sunwash of the holograms. And so when the direct sunlight is hitting the visor of the HoloLens, it essentially bleeds out or degrades the visibility of the digital assets or the holograms that you're seeing through the headset. And so now, for instance, Trimble has a HoloTint add-on that you can put in front of the visor that fits and clips on quite nicely. There's been some other workarounds that I've heard of, like including like ski mask film and things like that. But again, these are problems that have been overcome. The other thing too, over the evolution of these devices, is basically their battery life. I remember the first HoloLens was a bit of a challenge because it was running out of battery power or overheating quite a bit, especially out in the direct sun here in the southwestern United States where I live. And so, making sure that battery life or interchangeable batteries is a very key aspect to making these technologies work. Now, the other key piece here is, internet, connectivity out on job sites, and contractors have had issues with this for quite a long time. There's a variety of different creative solutions that are kind of coming up in order to achieve this. But also the software vendor side have also created offline modes where you could be in the job site trailer or at a hotel and essentially, download the content and things that you need for the day. And then you can basically go out on site, do your activities, even collect and capture data, and then synchronize that back with the cloud once you get connected back to the internet. So these are also things that you just need to evaluate and look at when you're considering augmented reality technology or mixed reality technology on the construction site. Now, there's some important takeaways here, and the most important thing is that when you're implementing augmented reality or mixed reality, you're going to have to do your homework. You really need to investigate the different hardware technologies as well as software applications that best integrate with those technologies in order to create the solution that you need. So you want to make sure you map out all of the use cases that you're looking to accomplish with augmented reality and what level of precision that you're looking for. Now, for me as a construction technology expert that's been looking at this tech for quite a few years now, really the biggest barrier to me has been just looking for that true seamless experience of alignment of the model in the physical space and making sure that you're working through drift and whatever solutions feel seamless. It's not a problem to have a tech actually go through, set up the alignment anchors and things that we sort of talked about here and kind of get that set up for the actual production users and inspectors on site or in the shop environment. But I just want to make sure that when users get to actually doing their production, that they do not feel a barrier of entry just to try to use this tech, because it degrades the value proposition that it offers. So again, really map out what you're looking for and just be prepared that there's going to be a little bit of a learning curve that you have to go through. And once this part of the technology, the alignment, stability, and usability comes in, where this almost isn't even thought about, you don't even notice that all of this magic is happening, then really that's where the software applications get to come in and focus on workflow and features, such as issue tracking and communicating with the back office and some of the other things that I've shown throughout my videos here with augmented reality. So really, if you're looking to get into this technology, feel free to reach out to me. I've been doing quite a bit of research, and I have a few connections with different technology vendors that allow me insight into kind of some of the different things that they're doing. And I would love to help you out in your process of getting started with augmented reality. If you found this content useful, please subscribe to our channel and press the alerts button to be notified when we upload new content.